vectors 1, day number 2, parallel, perpendicular, and angles between vectors. We're not going to do a proof today, but we're going to use a new formula, of which I'm not going to prove in this class because potentially it was done in honors pre-calc. But you won't have to worry about that at all. You'll just be held accountable for how to use it, not necessarily how to do it or how to come up with it. This is a really good practice problem. I'm not going to do it on these notes, but I might make a separate video for this. Okay, so the scalar product, right? The scalar product A times B is equal to the magnitude of A times the magnitude of B times the cosine of the angle between A and B. What are A and B? They're vectors, right? So the scalar product is equal to the magnitude times the cosine of the angle in between. All right, so here's vector A, here's vector B, and here's theta, just to give you a general heads up on what you're looking at. We're going to use this to identify parallel vectors, perpendicular vectors, and the angles between them. Okay, so on this slide, let's first consider two different scenarios, okay? If cosine, what would the cosine of theta equal if theta equaled 0? Right? So what is the cosine of 0 is what I'm asking you. Oops, that should be a 0. Well, that's going to be 1. I'm going to show you in a couple of minutes what that has to do with what the heck we're doing. Okay? The cosine of 90 equals what? Well, that equals 0. So the cosine of 0 is 1. The cosine of 90 is 0. It's going to show us, kind of prove to us, what the dot product is, or a scalar product, excuse me. Okay, so I times I. Okay, so let's consider this the I-axis, the J-axis, the K-axis. If I have two vectors, both I, by I mean vector A equals 1I, and vector B equals 1I. All right, if I multiplied those together, right, they are the same vector, right? So what would be the angle between those two vectors? Well, it'd be 0. So if the angle between those two vectors is 0, then what does that mean that I times I would equal, right? So if the angle between them is 0, and the magnitude of one of them is 1, the magnitude of the other is 1, what does that mean that this product will be? Well, this is cosine of 0, which is 1, times 1, times 1. So A times B has to equal 1. So in this case, since A is I and B is I times I has to equal 1. What will J times J equal? They're the same vector. It'll equal 1. And K times K will follow suit and will also be equal to 1. Now let's talk about the following. I times J. So I got I got J, I got K. Here's vector I. Here's vector J. We can assume that they're perpendicular to each other. So therefore, what can we assume about I times J? It'd be 0. Okay, what about J times K? It would also be 0, right? Because they're going to form a 90-degree angle, and likewise I times K. So this will make a whole lot more sense on the next page. So let's get to it. Okay, so here's the formal definition of the dot product, scalar product. I'm sorry, I keep getting that myself. Here's vector A, here's vector B. In general form, I've got x1i, y1j, z1k. B is x2i, y2j, z2k. So we keep it general. If we were to multiply these two together, right, it'd be a whole lot of foiling. Actually, it'd be first, middle, last, first, middle, last, first, middle, last, right? So I'd take x sub 1i times that, times that, times that. And guess what I get? I get this. I'm not writing it all out. I don't want to do all that. Okay, then I'd take y sub 1 times all three of these. And I get this. And then I take z sub 1 times all three. And I get this. So I get 9 components, right? That's complicated. Why does this have to be so complicated? It doesn't. Okay, let's highlight a few things that we know. I times j is what? 0. I times k is 0. J times k is 0. So let's find some zeros up here because it'd be really nice if we could get rid of some of them. I times j, this term will be 0. He gone. I times k, this term will be 0. He gone. J times I, this term is gone. J times k, this term is gone. It's going to be 0. Why? Because I times j, I times k, j times k, all 0. If you have 2 different letters here, k and I, and k and j, they're all going to disappear. So what do we keep? Well, we know this. We know each of these. I squared is 1, j squared is 1, k squared is 1. So that means that this right here, oops, wrong marker. I don't want that. Get away. Here you go. We're going to keep the green ones. Now I'm only highlighting the letters x and y and z because what's true about I squared, j squared, and k squared? They're all 1. Right? They're all 1. Therefore, in general form, if I have a times b, I get x1, x2 plus y1, y2 plus z1, z2. We're going to make a whole lot more sense out of that on the next page. Okay, so let's work through a little bit here. Here's an example. I'm given vector A, vector B. I want to find the magnitude of A first, so you can go ahead and pause the video and do that. The magnitude of vector A will be square root of 9 plus 1 plus 25, which is equal to the square root of 35. Okay. Vector B's magnitude will be the square root of 4 plus 16 plus 1, which is equal to the square root of 21. Now, A dot B, right? A times B is going to be, like we said, x1, x2 plus y1, y2 plus z1, z2. And here's why I love component form. Let me write this over here. Okay, here's A and B in vertical column form. I like this form when I do my products here. I take 3, negative 1, and 5. I take negative 2 and 4 and negative 1. And what I do is I multiply these together. I get negative 6. I multiply these together. I get negative 4. I multiply these together. And I get negative 5. It looks like, to me, A dot B is going to be negative 15. Okay, so here I multiplied the x's. Here I multiplied the y's. Here I multiplied the z's, right? So here are my z's. Here are my y's. Here are my x's, and then I add them up. Okay, so A dot B is equal to negative 15. So the cosine of theta, let's go back up for a moment. I took my formula and I divided by the magnitudes of A and B. So cosine of theta, the angle between the vectors, is going to be A dot B over A times magnitude of A, magnitude of B. So that's negative 15 over square root 21, square root 35. And of course, we could go a step further. We're not going to do it right now, but I could find the angle. I could find the angle between the vectors by doing the following. All right, I don't have my calculator with me right now, so I'm not doing that. That should be a 35. But that's it, guys. That's the that's vectors, parallel, perpendicular, and angle between. Cool. Like, subscribe, comment below. Love it.